Okay, let me set it up. In this presentation, we learn about the voyage data recorder. Now, a voyage data recorder can be very easily understood by going into the performance standards for the voyage data recorder equipment. These performance standards are given by resolution MSC 333-90 and they were adopted on 22nd May 2012. So we will be discussing this equipment through its performance standard. Right now you see the circular IMO resolution circular, which gives us the performance standards for the VDR equipment. The first part of the resolution gives us the reasons why these performance standards were brought in. Then in the second part, you see that the IMO has adopted the revised recommendation on performance standards for voyage data recorder. Now these standards were updated from July 2002. The first standards were brought in from July 2002 and these standards were revised on 1st July 2014. So we are discussing the standards which are in force after 1st July 2014. So the resolution recommends the governments to ensure that if a VDR is installed on or after 1st July 2014, it should comply with or conform to performance standards not inferior to those specified in the annex to this present resolution. At the same time, they have given a relaxation to the ships where VDR has been installed before July 2014. They can continue to comply with the performance standard which were specified in the earlier resolution A861-20. Now the first part of the resolution tells us about the purpose of the voyage data recorder equipment. The purpose of a VDR is to maintain a store in a secure and retrievable form of information concerning the position, movement, physical status, command and control of a ship over the period leading up to and following an incident having an impact thereon. Information which is contained in a VDR should be made available to both the administration and the ship owner. Basically, the ship owner is the owner of the VDR data and he has an obligation to provide this information to the administration for accident investigation and analysis. This information is for use during any subsequent safety investigations to identify the causes of the incident. Now, if an accident has happened, the only way to learn about that accident and to prevent it from repeating again is to learn from our mistakes. And this is exactly the purpose of a voyage data recorder, so that we can analyze the reasons, the causes which led into a particular accident, and later on we can eliminate them to make shipping more safer. Moving ahead now. We come to the definitions now. Voyage data recorder or VDR means a complete system including any items required to interface with the sources of input signals, the processing of the input signals and encoding whatever is required, the final recording medium also known as FRM, the playback equipment which is used to play back the VDR data, the power supply and the dedicated reserve power source. So all these are the parts of a voyage data recorder. A signal source means any sensor or device external to the VDR to which the VDR is connected and from which it obtains signals and data to be recorded. The final recording medium means the items of hardware on which the data is recorded, such that access to any one of them would enable the data to be recovered and played back by use of a suitable equipment. The combination of a fixed recording medium and float-free recording medium and long-term recording medium together is recognized as the final recording medium. So final recording medium basically consists of three parts. First one is the fixed recording medium, which is fixed with the ship, and in case of a unfortunate happening with the ship sinking, this fixed recording medium goes down with the ship. The second part of the final recording medium is a float-free recording medium. It is fitted with a HRU, and in the unfortunate event of a ship sinking, this will float free and remain on the surface. And the third one is a long-term recording medium. Long-term recording medium is just like a computer which is present on the ship, and it records the data for the longest duration possible. Moving ahead now, beta. Coming to standard 5.4, that is continuity of operation. VDR should be capable of operating from the ship's main and emergency source of electrical power. If the ship's source of electrical power supply fails, the VDR should continue to record the bridge audio from the dedicated reserve power source for a period of 2 hours. At the end of this 2-hour period, all recording should cease automatically. So this is what we discussed a little earlier, that we should have a dedicated reserve power source, basically a battery, solely for the purpose of the voice data recorder, which should continue recording for a minimum period of 2 hours after the ship has gone dead. Means there is no other power, normal power, emergency generator, battery power for the ship. Everything else is gone. It should continue to record the bridge audio for 2 hours period, and after this 2-hour period ends, the recording should cease automatically. Recording should be continuous unless terminated, as stated above. The time for which all stored data items are retained should be at least 30 days or 720 hours on the long-term recording medium. Now we are going to see what is the duration of time for which the data is recorded and stored. It is different for all the three parts of the FRM. We had the long-term recording medium, we had the float-free recording medium, and we had the fixed recording medium. So for the long-term recording medium, which is basically similar to a computer somewhere located in the accommodation, easily accessible place, the data should be recorded for a period of at least 30 days. That converts to 720 hours. So this much data is always available. Again, just to remind you, these are the minimum standards as per the IMO, and a particular maker or ship owner could extend this period to as much as he would like it to be. So the minimum period which is required is 30 days. So at any point of time, if you download the data from the long-term recording medium, you could get the data for the last 30 days. Most of the companies nowadays have a requirement that every 30 days the data should be downloaded and kept safely, so that you have a complete record of the entire navigational data available to you all the time. Now coming on to the fixed and float-free recording medium, there the requirement is at least 48 hours on the fixed and float-free recording medium. Now this is also a change which has come in the 2014 standards. Before 2014, the requirement was only for 12 hours. The data was required only for the last 12 hours. So you can see it has been extended to 400% now. From 12 hours, it has gone to minimum 48 hours on the fixed and float free unit. And in the long term unit, it has gone much more than what was required earlier. Instead of 12 hours, now we have 60 times more data recorded in the long term recording medium, that is 720 hours. Data items which are older than this may be overwritten with new data. So when this particular period is over, let's say you switched on a VDR, the long-term recording medium kept on recording the data for 30 days. Now on the 31st day, what will happen is that the previous data items, which has gone outside this window, 30 days window, 720 hours window, will keep getting overwritten with the new data which is being recorded continuously. Beta, any doubts coming up to here? Very good. Moving ahead. Now coming to an important standard, what all data items should be recorded in a VDR? The first data item which is there, the basic, that is the date and time. So date and time, reference to UTC, that is the GMT, should be obtained from a source external to the ship, and an internal clock should be synchronized with valid date and time data. During times of a loss of the external source, the internal clock should be used. The recording should indicate which source is in use. The recording method should be such that the timing of all other recorded data items can be derived on playback with a resolution and continuity sufficient to reconstruct the history of the incident in detail. So to put it shortly, the date and time is basically picked up by a GPS, and in case of a GPS failure, there is an internal clock which is provided, and the backup is taken from the internal clock in that case. Second data item is the ship's position, the latitude and longitude, and the datum used. Now this is also captured from the GPS, should be derived from an electronic position fixing system, in short known as EPFS. That's the GPS, or if some ship is having GLONASS, or some ship is having IRNSS, or Galileo is also coming up now. The recording should ensure that the identity and status of the EPFS can always be determined on playback. Let's say there are two GPS or two electronic position fixing systems fitted on ship. The recording should specify that this data was picked up from which GPS. And secondly, if there is any error or alarm which is coming in the GPS, which basically means the status of the EPFS, whether it is working fine or the position has some error, the recording should be such that we are able to determine it when we play back the data. Moving ahead now. Coming to the speed of the ship now. What is required to be recorded in the VDR is speed through the water and speed over the ground, including an indication of which it is, derived from the ship's speed and distance measuring equipment, also known as SDME. That is the log. It could be the Doppler log, it could be the EM log, as required by the SOLAS regulations. So these logs could give us speed through the water. Usually that's what we get in deeper waters. And when we are in shallow waters, the logs could also give us speed over ground. So it is recorded from the log, the speed, and whether it is speed through water or speed over ground, that also should be recorded in the VDR. The heading of the ship, heading as indicated by the ship's heading source. So that's basically the gyro. So that is recorded in the VDR. Next data item is the bridge audio. Microphones should be positioned on the bridge, covering all workstations as described in MSc Circular 982. So this circular explains in detail how the microphones should be placed or located on the bridge so that they cover all the workstations and all the important conversations are recorded. The recording should be such that on playback, a normal speaking voice should provide adequate intelligibility while the ship is performing its normal operations. So the quality of the recorded voice or the mic should be such that normal speaking tone, if it is used by the navigator, or by master, or by the lookout man or the helmsman, it should be adequately intelligible. Means you should be able to decipher what was being said. And it should be possible when the ship is performing its normal operation. That means any vibrations or any sounds, alarms, the mic should be such that even with those vibrations, alarms bringing in the bridge, sounds, different sounds coming in because of bad weather, maybe the sound of the wind hitting on the windows or the bridge wing doors. Even with all those disturbances coming, a normal speaking voice should be intelligible enough to be recognized. This performance should be maintained at all workstations. While there is a single audio alarm anywhere on the bridge or any noise, including noise from faulty equipment or mounting or wind, this should be achieved through the use of at least 2 channels of audio recording. Microphones positioned outside on bridge wings should be recorded on at least 1 additional separate channel. So there should be 2 different channels of audio recording, and bridge wings, the mics should be recorded on a separate channel. What does this mean is, you see on the bridge wings, usually the disturbance is much more as compared to inside the bridge. Especially during bad weather, there are a lot of sounds which may interfere on the mics which are positioned on the bridge wings. They are exposed to the wind, exposed to the weather. So for this purpose, there is a separate channel for the bridge wing mics. What do we mean by separate channel? We mean that if you want, at the time of playback, you could switch off the bridge wing microphones so that they do not interfere with you trying to listen to the conversation which is happening inside the bridge. So that is the meaning of a separate channel. Any doubts up to here, beta? Very good. नो बेटा, नो 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 नो, ये याद करने की ज़रूरत नहीं है. नाउ एज आई टोल्ड यू बेटा कि इसका अगर क्वेश्चन आता है तो 25 मार्क्स क्वेश्चन होगा. सो यू हैव टू राइट 25 वैलिड इंपॉर्टेंट पॉइंट्स. सो डाटा आइटम्स आर इम्पॉर्टेंट. आपको ब्रिज ऑडियो वहाँ पे मेंशन करना है. ब्रिज ऑडियो के नीचे आप यू जस्ट राइट ए कपल ऑफ लाइंस, दैट वुड बी एनफ. ओके, मैं आपको डिटेल में इसलिए लेके जा रहा हूँ बिकॉज समटाइम दे ग्रिल यू इन ओरल्स आल्सो, व्हाट आर दीज आइटम्स, हाउ आर दे रिकॉर्डेड. सो आई एम बेसिकली प्रिपेयरिंग यू फॉर द ओरल्स आल्सो रिलेटेड टू द NAVIDS क्वेश्चंस. Okay, let's move ahead. Okay, coming on to the communications audio now, the next standard. VHF communication relating to the ship operations should be recorded on an additional separate channel to those referred to in 555. 555 was bridge audio, and this particular standard is regarding the communications audio. What is the difference? Bridge audio is basically the audio being captured inside the wheelhouse. The master giving a command to the duty officer talking to or giving a command to the lookout man or the helmsman. All this comes under the bridge audio. Communications audio is the audio with which you communicate with third parties. Like say you have a separate ship, you want to communicate with that ship using the VHF. That would come under communications audio. Now the mic for this particular purpose, that is the communication audio or the VHF communication, should be on a separate channel. Means if you want to stop this particular mic, it should be independent of the bridge audio capture. So you can switch off the VHF communication mic, you can switch off the bridge wings mic separately, you can switch off the bridge communication mic separately. They are all on different channel and you can listen to them one by one. The advantage of having these different channels is that at the time of playback, if they were all recorded on a single channel, all these sounds may just mix in and it will or may not be possible for you to decipher or find out what was being said in the bridge. The voices may interfere with each other. The voice of the sound, the voice of the wind which is blowing on the bridge wing, the voice of a third officer communicating on the VHF with another ship, and the voice of the master giving command to the helmsman will all get mixed up. So it will not be able to find out what was happening at these three locations. So that's why they are on different channels. Whenever you want, you can switch off any of the channels. You can listen to any one of them. Later on during the second playback, you could switch off that particular one, listen to, like say for example, in the first recording, first playback, you could listen to what master command was given to the helmsman. In the second playback, you could switch off the master's voice and you could listen to what the duty officer was saying to the ship which was coming close on the VHF. And in the third playback, you could switch off both of these and you could listen to what was the lookout man telling to the master from the bridge wing. So all these could be listened to separately, individually. That's the advantage of different channels being used. Next standard relating to the radar. The electronic signals of the main displays of both the ship's radar installations as required by SOLAS. The recording method should be such that on playback, it is possible to present a faithful replica of the entire radar display that was on view at the time of recording, albeit within the limitations of any bandwidth compression techniques that are essential to the working of the VDR. So what this means is the recording should be such that on playback, it should be possible for you to present a faithful replica of the entire radar display. That means that when the system is capturing the radar screen, it should capture what was on view for the duty officer. That means if some VRM has been put or a EBL is being used for position fixing, that should be visible. If there are range rings which the duty officer has displayed, that should be visible in the VDR data. So it's basically going to tell the person who is looking at the playback what all was being done by the duty officer during this particular interval. Next is the ECDIS. Where a vessel is fitted with an ECDIS installation, the VDR should record the electronic signals of the ECDIS display in use at the time as the primary means of navigation. So if there are two ECDIS fitted, it will be capturing the screen of the one which is the display being used as primary means of navigation. The recording method should be such that on playback it is possible to present a faithful replica of the entire ECDIS display that was on view at the time of recording. So the same thing applies to the ECDIS screen picture grab. Not only the ECDIS picture should be picked up, but the VDR should also pick up what all the duty officer was doing on the ECDIS. So if there was a EBL picked up, if he was fixing up the position of the ship on the ECDIS, if there were range rings, or if he changed the safety depths, what all was being seen on the ECDIS, if he was zooming in and zooming out, changing the range. So all this should be captured by the VDR. Any doubts up to here, beta? Very good. Next, we come to the echo sounder, which gives us the depth information. Now, the VDR data which is recorded should include, where available, the depth under keel, the depth scale currently being displayed, and other status information. That means any alarms coming should also be captured in the VDR. Then next is the main alarms. This should include the status of all mandatory alarms on the bridge or as received from the Bridge Alert Management System. This in short is also known as BAMS. If installed, it is not a mandatory equipment as of now, but the IMO has already released its performance standards for the BAMS, and if it is fitted on board a ship, then this feed of the BAMS system should go to the VDR. And when this data is recorded in the VDR, it should be recorded as individually identified alarms. So if it is giving two alarms, you should be able to identify what alarms were being given by the BAMS system. Now you can see a BAMS Bridge Alert Management System here in the diagram. This BAMS system is basically connected to all the bridge equipment. So all the alarms are communicated to the BAMS system. This is connected to the VDR, providing data for recording. This is connected to the Bridge Navigational Watch Alarm System, BANWAS, and this will give a warning to the duty officer in case of any alarm coming in anywhere in the system. Did any one of you had this fitted on board, beta?
Yes, sir.
Okay. So was it useful, beta?
ये सेपरेट इक्विपमेंट नहीं था सर, ये आईएएस का पार्ट था सब कुछ.
Okay, okay, okay. All right, all right.
ये आईएएस में जो भी आपके मतलब अलार्म्स आते हैं वो सब इंडिकेट होते हैं कि भाई बैटरी उसमें बल्ब चला गया 24 वॉट लो इंसुलेशन सब कुछ ऑलमोस्ट सब कुछ. बट ये सेपरेट कोई इक्विपमेंट नहीं था, इंटीग्रेटेड था.
Okay, all right, beta, all right. So this is gaining importance now. So slowly you will see it on all the bridges. We come to the next standard or the data item which is recorded in the BANWAS, that is the rudder order and response. What is important to understand here is you see both the order as well as the response are getting recorded. It is not that you have given a command to the rudder. It is recorded in the VDR and the matter ends there. No, there could be a discrepancy. You may have given the rudder order, but the rudder may not have responded. That is the cause of many of the accidents which occur. The same is true with the engine orders also. So that is why there is a specific requirement that the rudder order as well as the response should be recorded with time. What was the order given? When was the order given? What was the response received from the equipment, from the rudder? When was the response received? So all these items are recorded. This should include status and settings of heading or track controller, that's the autopilot, if fitted, and indicate the control station, mode, and power units in use. So which control station are you using or ordering the rudder? Sometime there may be 2 or 3 control stations from where rudder order could be given. The mode, which mode you are using up, the follow-up, non-follow-up, all these things, and the power units which are in use. Usually we have 2 steering motors. So which one of them is in use? All this is recorded in the VDR. Next data items is engine and thruster order and response. So this should include the positions of any engine telegraphs or direct engine propeller controls and feedback indications on the bridge, if fitted, including ahead or astern indicators, and indicate the control station in use. This should also include any thrusters, if fitted, and indicate the control station in use. So the order, what has been given, any engine order or any thruster order, and what is the response which you have received, both should be recorded. Now this is to remove any confusion related to, see, many times when accident happens, you check with the navigators, they say we had given a engine order, let's say a full astern at this particular time, and it never came. The engine room people may say that we received the order at so and so time, and immediately the order was carried out, the feedback was sent to the bridge. So there could be a discrepancy on both of these fronts. So that is why the order as well as the response is recorded in the VDR. Next item is the hull opening status. So this should include all the mandatory status information required to be displayed on the bridge. Any hull openings are there, whether that hull opening is open or closed, so that should be recorded. Moving ahead now. Then the next data item, watertight and fire door status. This should include all mandatory status information required to be displayed on the bridge. Next is accelerations and hull stresses. Where a ship is fitted with hull stress and response monitoring equipment. Now this equipment is not mandatory as of today, but if it is present fitted on the ship, then all the data items that have been pre-selected within that equipment should be recorded. Then the next data item, wind speed and direction. Where a ship is fitted with a suitable sensor, wind speed and direction should be recorded, including its true or relative status. Then the AIS, all AIS data should be recorded. Then we come to another important addition here. This is also a new addition in the 2014 standards. The BAMS, which we discussed a little while ago, is also a newer addition in the 2014 standards. It was not there in the old standards. The rolling motion also included in recent standards. The VDR should be connected to an electronic inclinometer if installed. So you can see from these words, if installed, this is also not a mandatory equipment on the bridge as of now. This is having a recommendatory status. However, IMO has already come up with the performance standards of this particular equipment. Now, whenever you see such a equipment which is not mandatory right now, but the IMO has come up with its performance standard, that tells us that this equipment has its utility and it is going to sooner or later get mandatory to be fitted on the bridge. So in the near future, you are going to have this electronic inclinometer fitted on the bridge. And if it is there, the recording method, the data which goes to the VDR should be such that the rolling motion can be reconstructed during playback. So did any of you had this on board beta? Okay, all right. So not yet. Let's move ahead. Okay, coming on to another new equipment which is coming on the bridge gradually. The standard, the status is the same as an electronic inclinometer. This equipment is not mandatory as of now, but the performance standards have already been released by the IMO, and sooner I expect that this equipment is going to feature more and more on the bridge, and eventually it is going to become mandatory also. So where a ship is fitted with an electronic logbook in accordance with the standards of the organization, the information from this should be recorded. So did any of you have this electronic logbook on board, Peter? Okay, all right. So not yet. Great. So all these are hot oral questions. If you get across a surveyor who is taking NAVIT subject, then he will ask you all these things. Let's move ahead. Okay, so coming to the playback equipment now. This is also a new item which is made mandatory in the 2014 standards. This was not mandatory in the previous standards. The VDR should provide an interface for downloading the stored data and playback the information to an external computer. The interface should be compatible with internationally recognized format such as Ethernet, USB, Firewire, or a equivalent system. It should be possible to perform a download of the recorded data for a user-defined period of time. So that's the requirement now. Okay, so we are closing into the standards now. The last one, the portable storage device containing the software, the instructions, and any special which are not commercial off-the-shelf parts necessary for the physical connection of the external laptop computer should be stored within the main unit of the VDR. The basic purpose is that anybody or any authorities who would like to download this data, it should be readily accessible, and it should not happen that at the time of need, the software or the required items are misplaced or lost. Where non-standard or proprietary formats are used for storing the data in the VDR, the software for converting the stored data into open industry standard formats should be provided on the portable storage device or resident in the VDR. So with this, we complete the voice data recorder also, beta. I'm closing the presentation now. Okay, so any doubt you are having in the VDR beta anywhere you want to ask or share something?
सर अभी कोई रिक्वायरमेंट आया हुआ है क्या VDR की ऑडिट का? VDR ऑडिट से
बेटा ऑडिट तो नहीं है, इनकी एनुअल इंस्पेक्शन है. सो
एनुअल परफॉर्मेंस टेस्ट.
annual performance test should be there. So you should have a record. That is what I know last. If there are any changes, I don't know beta.
ओके. अभी हर 3 महीने में सर ये कोई VDR ऑडिट करके आता है, उसमें रिकॉर्डिंग मांगते 12-12 घंटे की.
Okay, it may be a company requirement beta, SMS requirement.
Yes, a company requirement is.
Maybe.
Yeah.
Better to sell with Japanese.
Okay. Yeah, it is mandatory now beta. After the 2014 standard, they made it mandatory. Before that, it was optional. Now you need to have it. So you can raise this thing beta requirement to the company. You can attach these performance standard and tell them we need a playback. Okay, but first check with the maker's manual. It is possible that जो आपकी file download हो रही हो, that format you may be able to play using off the shelf like Windows Media Player or some other kind of this thing. So then a separate software is not required. So first check that. If that is not being played on a normal computer in VLC player or Windows Media Player, then certainly you need to have. You need to have, otherwise you can have a objection, a NC kind of thing. Okay, great beta. So this was the voice data recorder. So अब बेटा हमारा एक ही इक्विपमेंट रहता है GPS, वो मैं आज पिकअप नहीं कर रहा हूँ. आई नो आज थ्योरी पढ़ते पढ़ते जो है you must be fed up by now. So or you want to go ahead with GPS? Tell me.
सर डाउट्स ले लीजिए अभी.
ओके ऑल राइट बेटा, ठीक है, आज डाउट्स ले लेते हैं.